In this video, we're going to learn about ionic compounds, and we're going to learn how to determine the chemical formula for simple ionic compounds and also how to name those compounds. So if you recall, all atoms want to acquire a valence shell like their closest noble gas. So they will either give up electrons to become positively charged, they'll gain electrons to become negatively charged, or they'll share 1, 2, or 3 electrons to get to that noble gas configuration. In an ionic compound, electrons are transferred from one atom to the other. The positive ion, so this one, sodium gave up an electron to chlorine, so it became a positive ion. It's called the cation. And then the negative ion, chlorine gained an electron from sodium, so it's the anion. Those oppositely charged ions are then attracted to each other and they form a bond between each other. So lithium and fluorine, for an example. And ionic compounds are always made of a metal plus a nonmetal. So we can practice with this by drawing the Lewis structures for lithium and fluorine and seeing the results. So if you remember, lithium is in the first column. It's in group 1. It's an alkali metal, so it has 1 electron. So we'll draw that electron here. And then fluorine is a halogen, so it has 7 electrons in its valence. So 1, 2, 3, 4, 5, 6, 7. So lithium, it would be way too hard to find 7 electrons. And it would also be impossible to share enough electrons because they can only share up to 3 electrons. So it can't fill its valence shell. So the only thing it can do is give away its electron to something else. And then fluorine has 7 electrons, so it's not going to be able to give all 7 away. It's going to try to find an electron from somebody else. So in this case, lithium will transfer its electron to fluorine, forming an ionic compound. So again, if you recall, chemical formulas tell us the number of each atom in a compound. So in this example, we have 2 lithiums for every oxygen. So if there's not a subscript number beside the element, we know that there's only 1. But if there is a subscript number, that tells you that there's 2 of the element that it's beside. So ionic compounds must be neutral, so their positive charges have to cancel out their negative charges. So the easiest way to figure out how that will happen is we use something called the crossover rule to determine the chemical formula. So we'll go through the steps of the crossover rule and follow them through with a few examples. So first of all, we write the symbol for each ion beside each other, and the metal always goes first. So in the example we're going to do, it's magnesium and chlorine. So we draw magnesium first and then chlorine beside it. Our second step is to write the charges of each ion above the symbol. So if we look up for magnesium, because it has 2 electrons in its valence ring, it's going to give up those 2 electrons and get a charge of 2. So we'll write 2 plus for the charge. And then chlorine is in group 17, so it wants to get to 1 more electron to become like the noble gas. So its charge is going to be -1. So some periodic tables will tell you the charges of each elements. Those are handy to have, but you can also figure it out by guessing how many electrons away from the closest noble gas it is. So the third step is to cross over the magnitudes of the charges so that they become the subscript for the other atom. One thing to note is that you don't write down a 1, you just leave that out. So we'll bring down the 2 beside chlorine, and we'll bring down the -1 down here. We'll just write it for now. So a 1 goes there. And then you reduce the charges if necessary. So remember, we brought down the 1 here, so we don't need to write the 1. And then we brought down a 2 here. So the chemical formula for magnesium and chlorine combined together is MgCl2. In our next example, we're going to work with magnesium and oxygen. So magnesium, we know from the last example, gets a charge of +2. Oxygen is in group 16, so it wants 2 more electrons, so it's going to get a charge of -2. So we'll cross over those magnitudes like so. So the 2's come down, so it would end up being Mg2O2 if we rewrote it. We can reduce that down because both of those numbers could be divided by 2. So the chemical formula for magnesium bonded with oxygen is MgO. Our next example is aluminum and oxygen. So aluminum is in group 13, so it has 3 electrons. So it's going to give up those 3 electrons to get a positive charge. So it's going to get a charge of +3. Oxygen is still in group 16, so it still wants 2. So it's going to have a charge of -2. And then we're going to cross those charges down like so. So we'll rewrite this to be Al2O3. And in this case, we can't reduce those charges. We can't reduce the formula at all. It's just, that is the formula, Al2O3. Now, one thing that you probably have noticed is there are charges up here, but we don't bring down the symbol for the charge when we do the crossover. Those are just helping us see that they're canceling each other out. So you have to have positive charges and negative charges to cancel each other out. Now, to name ionic compounds, you write the name of the metal first, followed by the name of the nonmetal, and you change the ending of the nonmetal to IDE. So with magnesium and oxygen, it would be magnesium oxide. Aluminum and oxygen would make aluminum oxide.